According to the National Electrical Code, or NEC, a plenum is defined as a compartment or space that forms part of the air handling system of a building and is designed to carry air or has been frequently used to carry air. To determine if a space below a raised floor is a plenum, several factors must be considered. In the scenario described, the space below the raised floor is used for cabling and for air movement to cool electronic equipment in racks. An outside blower directs air into the space, and the space is sealed to prevent the spread of smoke or flames to other rooms. Based on the NEC definition and the specifics of this installation, the space below the raised floor is not considered a plenum. This is because the air movement is solely for cooling electronic equipment and is not part of the building's overall heating, ventilation, and air conditioning or HVAC system. The sealed nature of the space further supports the determination that it is not a plenum, as it does not serve as a pathway for air circulation within the building. Since the space is not a plenum, plenum-rated cabling is not required. However, all cabling must be installed in accordance with the NEC and any applicable built-in codes for the specific installation. Here are some recommendations for this type of installation. Firstly, use non-plenum rated cabling that meets the requirements for the application. Secondly, install cables in a secure and organized manner within the space below the raised floor. Thirdly, ensure that all electrical equipment is properly grounded and bonded to prevent potential electrical hazards. Now let's elaborate on each of these points. Firstly, regarding non-plenum rated cabling, it is essential to select cabling that is appropriate for the environment and the specific application. This includes considering factors such as voltage rating, temperature rating, and resistance to environmental factors like moisture or chemicals. The NEC provides guidelines for selecting the correct type of cable for different applications, and it is important to consult these guidelines to ensure that the chosen cable meets the necessary requirements. Secondly, the installation of cables in a secure and organized manner is crucial for both safety and maintainability. Cables should be properly supported and secured to prevent them from becoming damaged or creating a tripping hazard. Cable trays, cable ties, and other support systems can be used to organize and manage the cables. Labeling cables is also important for ease of identification and troubleshooting. Thirdly, grounding and bonding of electrical equipment are essential for preventing electrical hazards. Grounding provides a path for fault current to flow back to the source, which helps to trip the circuit breaker or fuse and to energize the circuit. Bonding connects all metal parts of the electrical system together, which helps to equalize the voltage and prevent electrical shock. The NEC provides detailed requirements for grounding and bonding, and it is important to follow these requirements to ensure a safe electrical system. Now let's dive deeper into the NEC requirements for cable installation. Article 300 of the NEC covers general wiring methods and materials. This article provides requirements for the installation of cables in various locations, including underground, in walls, and in ceilings. It also covers requirements for the protection of cables from physical damage, such as conduit and cable trays. Article 310 of the NEC covers conductors for general wiring. This article provides requirements for the ampacity of conductors, which is the maximum current that a conductor can carry continuously without exceeding its temperature rating. It also covers requirements for the insulation of conductors and the identification of conductors. Article 725 of the NEC covers Class 1, Class 2, and Class 3 remote control, signaling, and power-limited circuits. This article provides requirements for the installation of these types of circuits, which are commonly used for control systems, alarm systems, and communication systems. When selecting non-plenum rated cabling, it is important to consider the specific requirements of the application. For example, if the cabling is exposed to moisture, it should be rated for wet locations. If the cabling is exposed to high temperatures, it should be rated for high temperatures. It is also important to consider the voltage rating of the cabling and ensure that it is sufficient for the application. When installing cables, it is important to follow the manufacturer's instructions and the requirements of the NEC. Cables should be properly supported and secured to prevent them from becoming damaged or creating a tripping hazard. Cables should also be protected from physical damage, such as by using conduit or cable trays. When grounding and bonding electrical equipment, it is important to follow the requirements of the NEC. Grounding electrodes, such as ground rods or ground plates, should be installed in accordance with the NEC. Bonding jumpers should be used to connect all metal parts of the electrical system together. It is also important to ensure that the grounding and bonding system is properly tested and maintained. Let's consider some specific NEC sections that are relevant to this type of installation. NEC Section 300.11 covers securing and supporting wiring. This section requires that wiring be securely fastened in place and supported in accordance with the NEC. NEC Section 300.14 covers length of free conductors at outlets and switch points. This section requires that a certain length of free conductor be left at each outlet and switch point for making connections. NEC Section 310.15 covers ampacity of conductors. This section provides tables and guidelines for determining the ampacity of conductors based on their size, installation type, and installation conditions. NEC Section 250.8 covers connection of grounding and bonding equipment. This section provides requirements for connecting grounding and bonding conductors to equipment and to the grounding electrode system. NEC Section 250.134 covers equipment grounding and equipment grounding conductors. This section provides requirements for grounding equipment and for the size and type of equipment grounding conductors. Now let's talk about some additional considerations for this type of installation. It is important to consider the potential for electromagnetic interference or EMI. EMI can disrupt the operation of electronic equipment and cause data errors. To minimize EMI, cables should be shielded and properly grounded. It is also important to keep cables away from sources of EMI, such as motors and transformers. Another consideration is the potential for static electricity. Static electricity can damage electronic equipment and cause data loss. To minimize static electricity, the space below the raised floor should be properly grounded and the humidity should be maintained at a comfortable level. It is also important to use anti-static mats and wrist straps when working with electronic equipment. In addition to the NEC, there may be other applicable building codes and standards that must be followed. These codes and standards may cover topics such as fire safety, accessibility, and energy efficiency. It is important to consult with the local building department and other relevant authorities to ensure that the installation complies with all applicable requirements. Finally, it is important to document the installation thoroughly. This includes creating a detailed wiring diagram, labeling all cables and equipment, and keeping records of all inspections and tests. This documentation will be helpful for troubleshooting problems and for making future modifications to the system. In summary, when installing electronic equipment in a room with a raised floor where the space below the floor is used for cabling and air movement for cooling, it is important to understand the NEC definition of a plenum and to determine whether the space qualifies as a plenum. If the space is not a plenum, plenum-rated cabling is not required, but all cabling must be installed in accordance with the NEC and any applicable building codes. It is also important to follow best practices for cable installation, grounding and bonding, and EMI and static electricity control. By following these guidelines, you can ensure a safe and reliable installation. Let's delve deeper into specific aspects of cable selection for non-plenum spaces. When choosing cables, consider the environment they'll be in. Is it a dry, climate-controlled space, or could there be moisture or temperature extremes? For dry environments, standard non-plenum rated cables are generally sufficient. However, if there's a chance of moisture, opt for cables with moisture-resistant jackets. Similarly, for areas with high temperatures, use cables with high temperature ratings. The voltage rating of the cable is another crucial factor. Ensure that the cable's voltage rating is adequate for the intended application. Using a cable with an insufficient voltage rating can lead to insulation breakdown and potentially hazardous situations. Cable shielding is important in environments with electromagnetic interference. Shielded cables have a metallic layer that helps to block electromagnetic fields, preventing interference with the signals carried by the cable. The type of shielding depends on the specific application and the level of interference expected. Braided shields offer better protection than foil shields, but they are also more expensive and less flexible. Cable flexibility is a consideration, especially in tight spaces or where cables need to be routed around obstacles. More flexible cables are easier to install and less likely to be damaged during installation. The cable jacket material affects its durability and resistance to environmental factors. Common jacket materials include polyvinyl chloride, or PVC, polyethylene, and polyurethane. PVC is a general-purpose material that is cost-effective and provides good protection against abrasion and chemicals. Polyethylene is more resistant to moisture and ultraviolet, or UV, radiation. Polyurethane is highly abrasion-resistant and flexible. Now let's discuss cable installation practices. Proper cable support is crucial to prevent strain on the cables and their connections. Use cable trays, J-hooks, or cable ties to support cables at regular intervals. Avoid over-tightening cable ties, as this can damage the cable jacket and insulation. Maintain adequate spacing between cables to prevent overheating and ensure proper airflow. Bundling cables too tightly can trap heat and reduce their ampacity. When routing cables, avoid sharp bends, which can damage the cable and reduce its lifespan. Use gentle curves instead. Protect cables from physical damage by routing them away from areas where they could be stepped on, crushed, or cut. Use conduit or cable trays to provide additional protection in high-risk areas. Label cables clearly at both ends to facilitate identification and troubleshooting. Use a permanent labeling system that is resistant to fading and abrasion. Leave sufficient slack in cables at connection points to allow for easy maintenance and repairs. Avoid stretching cables too tightly, as this can damage the conductors and insulation. When making connections, use appropriate connectors and tools. Ensure that connections are secure and properly insulated. Avoid using damaged or corroded connectors. Grounding and bonding are essential for electrical safety. Grounding provides a path for fault current to flow back to the source, tripping the circuit breaker or fuse and energizing the circuit. Bonding connects all metal parts of the electrical system together, equalizing the voltage and preventing electrical shock hazards. Ensure that all electrical equipment is properly grounded and bonded in accordance with the NEC. Use appropriately sized grounding conductors and bonding jumpers. Test the grounding and bonding system to verify its effectiveness. Use a ground resistance meter to measure the resistance to ground. The resistance should be low enough to ensure that fault current can flow back to the source quickly and safely. Now, let's delve into electromagnetic interference mitigation. Identify potential sources of EMI in the area, such as motors, transformers, and radio transmitters. Keep cables away from these sources of EMI. Use shielded cables to block electromagnetic fields. The type of shielding depends on the level of interference expected. Ground cable shields properly to provide a path for EMI to dissipate. Connect the shield to ground at one end only to prevent ground loops. Use filters to suppress EMI on power lines and signal lines. Filters are designed to block specific frequencies of EMI. Use twisted pair cables to reduce EMI. Twisted pair cables have two wires that are twisted together, which helps to cancel out electromagnetic fields. Maintain good grounding practices throughout the electrical system. A well-grounded system is less susceptible to EMI. Now let's discuss static electricity control. Static electricity can damage sensitive electronic components. Maintain a relative humidity of 40 to 60% to reduce the build-up of static electricity. Use anti-static mats and wrist straps when working with electronic equipment. These devices help to dissipate static electricity safely. Use anti-static cleaning products to clean surfaces in the area. These products help to prevent the buildup of static electricity. Use anti-static packaging to protect electronic components from static electricity during storage and transportation. Ground all metal objects in the area to provide a path for static electricity to dissipate. Now let's consider the importance of proper documentation. Create a detailed wiring diagram that shows the location of all cables and equipment. Label all cables and equipment clearly and accurately. Keep records of all inspections and tests performed on the electrical system. Maintain a log of any problems or repairs that have been made to the electrical system. Store all documentation in a safe and accessible location. Ensure that documentation is updated whenever changes are made to the electrical system. Review documentation regularly to ensure that it is accurate and up to date. Effective documentation is essential for troubleshooting problems and making future modifications to the electrical system. It can also be helpful for complying with regulatory requirements and insurance purposes. Finally, remember that electrical safety is paramount. Always follow safe work practices when working with electrical equipment. To energize circuits before working on them whenever possible. Use appropriate personal protective equipment such as gloves, safety glasses, and insulated tools. Never work on electrical equipment when you are tired or distracted. If you are not comfortable working on electrical equipment, consult a qualified electrician. Electrical work can be dangerous, so it is important to take precautions to protect yourself and others. By following these guidelines, you can ensure a safe and reliable installation of electronic equipment in a room with a raised floor where the space below the floor is used for cabling and air movement. Remember to always consult the NEC and other applicable codes and standards to ensure compliance.